Hi folks, I just wanted to do a quick walkthrough description of the difference between SVP64 horizontal horizontal first mode and vertical first mode. And so what we're going to do is going to write down some instructions and how they will be, how the elements will be done in the register file. So the first thing is you have a loop. And so your C code will be something like for I equals 0, I less than, let's say R3, I plus plus, and a simple statement, R4 brackets I plus equals 5, okay, all right. So real simple, very basic program, right? So here you would have a setVL instruction. Let's say R1 is the destination to receive the what VL is, set VL I think, and R3 is the register with the loop, comma. And MVL equals 8. Okay, right. You then do an sv.load on R4. R4 is our destination. I think that was at R4. Yep, there we go. Comma. Well, do you want? I should have written these out already, actually, to be honest. But hey, R0 bracket 0, whatever. You know, that's just to get the thing. Now this will, when R3 is greater than or equal to 8, because MVL is maximum vector length here is 8, you end up this will do loading of 8 elements. SV dot add I R4 comma, and we wanted to add hash 5, and then SV dot store R4 comma R0 bracket 0, and the next thing you need is now let's actually tell you what, let's make this let's keep it in R3. You want sub R3 needs to subtract R1. I'm going to assume that there is a times 8. This is a load here, assuming this is a double word, a long or else I'll say this doesn't exist in Power, but let's assume that it does. So R1 times 8, subtract that, and branch not equal to 0, back to loop. So when R3 hits, when R3 hits 0, you can end the program, but otherwise you can loop back. Now, let's now draw out the register file here, and I'm going to assume 32 registers here, but also what we're going to do is 0, 1, 2, 3, 4, 5, 6, 7. That's 0, 8, 16, 24, okay, right. All right. Now, where were we? R3. Let us assume that contains 17. Okay, value 17. On the first instruction here, set VL R1 R3 with maximum vector length of 8. because R3 contains 17, R1 gets set to the min of 8, 17, which will be R1 will set to 8. Okay, and R4. Let's make that 8. Okay, R8, R8, R8. Oh, and also with yeah, sorry, I've missed out an instruction here. Sub R8 add, but sub R where is it? R3, comma R1. So what we're doing here is we're incrementing the pointer R8 by the amount that will move along to the next batch of 8 variables in memory. But the R3 R1 contains the number of elements that was actually done at this particular time, at this point and through this iteration of this loop, and that R1 gets subtracted from R3. So when you go back, you're doing the next 8 and the next 8 and the next 8 and the thing. So the pointer in memory moves on by 8 times 8 because we're loading. This is a long. But the actual counter decrements by only by 8. Now, so oh, I have messed it up. I'm so terribly sorry. Load from R8 into R8 from R4. Sorry. Yes. Okay. Sigh. Store R4. We need for both. I'm terribly sorry about this. Add R8 elements. Add R4 as the pointer. So R4 contains the address. R8 contains the actual data loaded from that address. I'm terribly sorry. The thing. All right. So let's see. This is 0x to 2000. Okay. This load for from R4 into the addressor into R8, you will end up with the values at memory location 2000. Let's say we've got to address 2000 and 2008. You've got the value 1, 2000 and 2010. Let's do this in hexadecimal 2018 to thing. Let's say we've got the values 1, 3, 5, 7. 9, just because. Okay, so when you execute this load instruction, you end up here with the values 1, 3, 5, 7, 9, 11, 13, 15. Okay. Now, 8 values get loaded into the register file in 8, 9, register R8, R9, R10, R11, 12, 13, 14, 15. Then we go on to the add I, and he adds 5 to each of those. So we end up with 6, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 3, 8, 5, 10, 12, 14, 16, 18, 20. Okay? Then you get the store. The store instruction will write that out, those values out 8 at a time, because the maximum vector length is still, the VL has still been set to 8, and a copy of VL is in R1 by a coincidence or by design of the set will instruction. So here that gets written out to memory, gets written out 6, 8, 10. 12, etc., etc. Now, next instruction, R4 gets incremented by R1 times 8. R1, which the thing is 8, so 64 88 to 64, and that is R4 gets set to 2040. Okay, 2040. This will be, let's say this is 20, 204821, 205022. Right. So then R1 gets subtracted from R3, which is our count variable from the original C code. R3 gets subtracted by 8, so the value in R3 gets replaced here. 17 minus 8 is 9. Okay, in R3. Okay, so let's draw that out again. 1, 2, 4, 5, 6, 7. Okay, so 1, 2, 3, 4. So here we have the now have the value 2040, and here we have the value 9, and we're going back to the set VL instruction. Now the min of 9 and MVL is 8. The min of 9 of 8 is again 8. Okay, so R1 gets set to 8, but VL, vector length, also gets set to 8. Now we have come to the SV load instruction from R4. R4, remember, has moved on to address 2040, and the destination is R8, so we want to load into the contents of here, and this is 8. So we get, from memory, we get loaded the values 20, 21, 22, 23, etc., etc. And it's basically a repeat of exactly what was just done here. Now, the interesting one is that this value here, on when you get down to here, add R8, R1 times 8, this gets replaced with 2080, and here this gets replaced with the value 1. Okay. Now let's assume, just because I've written them out here, that address 2080 also has the values 20, 21, 22, etc., etc., so we don't have to cross those out. Right. Now we subtract R3. Yeah, I subtract R1 from R3. So 9 minus 8 is 1. And when we go back into the loop again the next time, R3 only has a value 1. So the min of 1 and the maximum vector length 8 is 1, not 8 this time. And this is the whole reason why Cray-star vectors are infinitely freaking superior to SIMD. Okay, it's real simple. Okay, you do not have the bullshit set up and tear down that you have in strip mining, which you have with SIMD instructions. This is your entire loop, and it copes with any value of input for R3, including 0, interestingly. So in this particular case, despite the fact we've got in memory locations 20, 28, 22, 88, and 2090, etc., in hex thing, the vector length and R1, which is a copy of that, the VL, have both been set to the value 1. So what gets loaded is only, on this SV load instruction, only one value gets loaded. Okay, SV.load, vector length is 1, into R8 only, so one value. When this add instruction occurs, only 5 is added to that one value, and the replacement value becomes 25. And corresponding on the store, because again R1 is set to that 1, which in the VL, which is a copy of VL has been set to 1. Only one store occurs, and the value 25 is written to R8, which is 2080. So this value here gets updated to 25, not this one and not that one. So we can see that we had 17. We started out with a value of 17, and we had 17 values written. The memory address is 2000 was the first one. If in the first 8 batch, then the second 8 batch, and finally one last value for the 17th value. Okay? Now, that was in horizontal mode, and the reason why I wrote out the register file like this was to illustrate that it is horizontal. But effectively what it's doing is it's going, as if you can imagine this instruction here written out as a loop going load from R8, load into R8, load into R9, load in R10, 11, 12, Okay. Vertical mode. Pretty much exactly the same program. Yeah. Right. But we do SV set MVL hint. And let's say that we set that that the MVL equals 8, but the VF hint equals 2. Okay. Otherwise, it's to say pretty much the same thing. Set VL R1, R3. We won't set the MVL here because we've already done it. But what we are going to do is going to do vertical first mode equals 1. Okay. Now, there's actually, you need to use 2 loops, in fact, here, an inner loop and an outer loop. But I'm only going to describe the inner loop here. I think, all right? sv.load R8, R4, R4 bracket 0. Okay, so we're loading from the, it's R4 brackets I plus equals 5, for I equals 0, I is less than, what was it again? R3, I plus plus. Okay, all right. SV dot add I R8 comma hash 5 and SV dot store R8 comma R4 0. Same thing. Now, here's the key difference. So we actually have to do an explicit SV step, and we need to get the contents of that back into something to SV steps dot. Okay, all right. Just do SV step dot. Okay, and that will set condition register 0 when we meet the things. I'll explain in a minute. And branch if not non-zero, that's based on that condition register test, to inner loop. We need an outer loop as well, but I won't. Actually, I will do it. It's basically the same as here. Add R8, add R8, comma R1 times 8. That instruction doesn't, remember it doesn't exist in take sub R1 comma R3 BNZ loop. Okay, so whilst this one goes around here, this one is going to here. I won't explain the reasons why this exists, why you would want to do this. I'll save that for another time. It's related to I won't go over that now. Now again, let's do our register file. Five, 6, 7. Whoops, a bit of a mess there. 1, 2, 3, 4, 5, 6, 7. 0, 8, 16, 24, ... All right. Now, it's worthwhile spelling out here that we have VL, MVL, source step, and des step. But for the illustrative purpose, we're going to treat those two as the same. Okay, they're not the same if you involve predication, but we'll just talk about one of them as being, there's the same value, and VF hint. Now, the first iteration around here, R3 is 17. R4 is still pointing to 2000. Nothing has been set. So let's do this first instruction. Set MVL equals 8, VF hint equals 2. So MVL 8, VF hint 2. But source step and des step will be 0, and VL has not been set. Now come on to the next instruction, where it requests vertical first hint mode. R3 is 17. R1 is the destination, so we get a maximum. It calculates that VL equals maximum of MVL, which is 8, and R3, which is minimum of 8, 17, and sets it to 8, just as it did before. Okay. Now, here's where the difference lies. When this instruction is executed, because we are in vertical first mode, and because VF hint has been set to 2, only 2 elements get executed, not the entire 8, despite the fact that VL equals 8. So only 2 elements are loaded from memory. 2000 has the value... what did we have previously? We had the value 1. 2000 has value 1. 2008 has the value 3. So you get loaded into, you get value 1 and you get the value 3 loaded. Then we go into the add instruction. And we add on 5 onto those. So that value 1 gets replaced with 6, and this value here gets replaced with 8. Bear in mind, because vertical first hint is 2, that we are only doing 2 elements. Okay. Then we do the store, which writes out those values. Again, vertical first hint equals 2, only writes out 2 values, 6 and 8. Then we do the SV step instruction, and this is where it explicitly moves source step and des step on. So source step and des step both get replaced with the plus equal of with adding on the vertical hint, not VL. The priority in vertical first mode is VF hint is what you do, step you step on by. And because source step and des step have not reached VL, this BNZ this is CR0.EQ gets set to to 0, and it's because it's not 0, it branches back to the inner loop. Now, because source step, so when we now execute this SV load, source step and des step are set to 2. R8 plus 2 is R10. 2020, that has the value 5. 5 is loaded from memory, offset of R4, source step plus R4 times 8. And the value 5 is loaded into register 10. Then, because VF hint is 2, we're doing 2 elements. You do the next one, which goes into register 11. So the value to 202 memory from thing gets loaded and put into R11. Because remember, source step is 2, but we're doing 2 elements. So 2 now 3 plus 8 is 11. Okay. So now we've it's 11. We've moved on. We moved on 2 elements. And the thing now. So you can see how that would work. It would go round and round and round. You would load those values from 5 plus 8. You would end up with the value 10. 7 everything. You would end up 12. Then you go round the loop again. You do the next 2 values and the next 2 values and the next 2 values. And finally, the source step would get set to a value of 8. Because that 8 equals VL, condition register 0, EQ, will be set it will be set true, and the inner loop branch here test would fail, and you would come out of this inner loop and into the outer one, which is where it is otherwise identical to a thing. So at that point, the pointer here R4 is moved on to a value of 2040, and at that point, saying sub R1, R3, that gets replaced with the value 9. And then it goes back round again, because that has not reached 0. You then go repeat the process again, but you think that the point is that it's doing these 2 at a time. Okay, because VF hint is set to 2. All right. A thing. So that basically it explains why explains what the difference is. That you do the vertical first. It goes. If your register file is it's laid out, you're going vertically down through the instructions to do the elements, whereas in horizontal mode, you stick on the instruction and repeat the elements, all of the elements on the instruction. So that's why we call it this one's called vertical first, because you go vertically through the instructions with this inner loop, the thing. Whereas the standard Cray-style one, its elements are done on that instruction. Okay, so hope that helps. Thank you.